Hello friends, welcome to another video of Zeta Axis, and today we are going to discuss about the 13th chapter of GC Leong, that is weather. In this video we will see different parameters which are used to measure atmospheric conditions. We will see what are those parameters and how they are measured. So let's first try to understand what is the difference between weather and climate. So weather is atmospheric conditions at a place at a given time, while climate is an average atmospheric condition of a region over a considerable time, and this time should be approximately 35 years average. So we can see that weather is daily atmospheric condition. So it could be rainy weather yesterday and it could be sunny day today. So you can say for the same place that yesterday it was rainy weather and today it is sunny weather. But for the climate of that place, it will remain constant because the average atmospheric conditions are taken over 35 years, and therefore it will have a specific characteristics throughout the duration. So it requires systematic observation, recording and analysis to determine the climate of a region. Weather of a region you can just say by observation or by experience of that place at that time, but for climate you need to observe, perform analysis and measure these parameters. Only then you can determine the climate. Now to understand the difference between weather and climate, we can take example of Delhi. So from Jan to February, we know that there is western disturbance and there is rainfall during this duration, and the temperature is also on the lower side. It is around 10 to 15 degrees Celsius. Therefore, it is rainy and cold weather. This is the most general type of weather in Jan and Feb. When we come to March and April, it is very dry and warm, and this continues till May. So here the rainfall is very less or insignificant rainfall occurs and the temperature also rises. Therefore, it is dry and warm weather during the March, April and May period. When we come to June, July and August, we see rainy and warm period. Temperature is high. Rainfall is also very high. Therefore, we have rainy and warm weather. And then when we come to September, October, we see moist and warm weather is there. So the temperature has slightly reduced. Rainfall has also reduced, so moist and warm. And when we come to November and December, we see cold and dry period or cold and dry weather, because here there is very little rainfall or no rainfall and the temperature has decreased. So we can see that in the same place in Delhi, we have these different types of weather throughout the year. But the climate of Delhi is tropical monsoon climate. So even if it's January or it's June or it's October or it's December, the climate will always be tropical monsoon climate. However, the weather changes throughout the year. The climate does not. Now, there is degree of variability between climate and weather. Now, there are places where you will see that the climate, even though it has a same name, but throughout the year it varies. So we have seen the example of Delhi that the weather varies throughout the year. Similar is for Britain. We will see 4 distinct seasons in Britain, and therefore we see 4 different types of weather in Britain throughout the year. And it is because of this we say Britain has no climate, only weather, because there is no consistent feature in Britain. Like in Sahara Desert, you will have warm temperature throughout the year. But here you have different types of atmospheric conditions throughout the year. Therefore, Britain has no consistent climate but only weather. And therefore, we say that because of high variability in the climate, so climate has high variability over here. But when we go to Egypt, we say it has no weather, only climate, because every day the temperature and the rainfall characteristic is almost constant throughout the year. The temperature is high, the rainfall is low to medium. And because of that, we say that there is no weather, only climate, because same type of atmospheric conditions it persists throughout the year. Now let's try to understand the importance of climate and weather. Now, the type of climate and weather determines the type of food we eat, the clothes we wear, and our life and work choices. So we can see over here that these are the 3 images from 3 different climatic zones. And we can clearly see that the food which will be consumed in the desert will be different from the food which will be consumed in the monsoon region and the food that will be consumed in the polar region. Here mostly the food will consist of non-vegetarian items, and it will also be mainly of fishes or the local animals which are found over here. Here you will see that rice is the general consumption in the monsoon region of India, and here deserts, they will have their own cuisines and own plantation and vegetation that they consume. Our mental alertness also depends on the climate. It is generally believed that the tropical regions, because of high humidity and heat, it causes discomfort, and therefore the mental alertness will decrease in these regions. Our physical characteristics also get shaped by the climate and weather. The direction of wind earlier controlled trading routes. So in the medieval or ancient period, the wind directions, they determined the regions with which you can perform trade. Remember, the monsoon winds or the monsoon winds, it helped in trade between Saudi Arabia and Indian subcontinent in the medieval time. Here, when the winds were blowing from southwest direction, that is from Indian Ocean towards India, then the Arab traders will migrate or will travel from Saudi Arabia towards India, and when the winds reverse, northeastern winds flow, they will go from India towards Saudi Arabia. So this is how even the winds controlled the trading in ancient times. The crops that are produced is also determined based on the climate. Disease transmission is also slightly dependent on the climate. Mostly in the tropical regions, we see that because of humidity, a lot of vectors are found there, and therefore a lot of disease related to vectors is found in the tropical region. Now, rainfall is an important parameter for measuring the climate of the region. Rainfall along with snow, sleet, hail is measured using an instrument called rain gauge. So the rain gauge is a cylindrical instrument. It is something like this. Earlier it used to be of a copper or a metal funnel, but now it is generally of glass funnel, so we can directly take measurement without requirement of taking this instrument out and then transferring the water to another device. So now it is of glass. Earlier it used to be of copper. It has a metal funnel. You can see there is a glass funnel over here, and it leads into this small container which has this scale. So water which is falling from the sky, it will collect in this funnel and then will be transferred in this tube, and here we can get the measurement. Now remember, this funnel is used because to prevent the evaporation of this water. If this was a broad opening, then the water could easily evaporate back. But because of this narrow opening, the evaporation is reduced. Here we can say it leads into small container. Hole in funnel is small to stop evaporation of collected water. The gauge is kept 1 foot above the ground. So you can see that here is a wooden post and then this rain gauge is attached to it. So it is kept above the ground level, and it is also kept away from tall buildings or tall trees to get the accurate measurement. Rain measurement is done by measuring the water collected in a special cylinder. Measurement shows depth of water that would have collected on the ground if water was stagnant and did not evaporate or run away. So basically this measurement, it shows the amount of water that would have collected on the ground had the water not moved away or absorbed by the soil. So this is the level of water or the height of the water that would have collected on the ground. Now there are specific terms related to rainfall. One is rainy day. So any 24 hours with greater than 0.01 inch of rainfall is called a rainy day, while a wet day is any 24 hours where the rainfall is greater than 0.04 inches. Mean annual rainfall is the average of annual rainfall taken over a long period of say 35 years. So in the videos, when you will see that different climatic regions are given the amount of rainfall. So it is based on a 35 years average. So you will see that there would be a monsoon climate which has rainfall around 200 centimeters. It will be based on a 35-year average. Isohyet are lines which join places having same mean annual rainfall. So here in case of India, we can see these are the lines which are joining the regions which has same mean annual rainfall. So this helps us indicate the distribution of rainfall in a region, and these are called isohyet lines. Now another important characteristics or parameter for measuring the atmosphere is pressure. Now what is this atmospheric pressure? So we know that there is atmosphere above the lithosphere. This is a column of air. Now because this column of air has mass, it exerts weight on the lithosphere, on the surface of the earth. So this weight or the downward force of this column of air is called atmospheric pressure. So it is the weight exerted by air column, and air pressure varies from one place to another. So because of specific regions, like there is change in atmospheric conditions like high pressure region or low pressure region, or air is descending or air is ascending, because of all these characteristics the pressure in a given region can vary. Barometer is a device which is used to measure the atmospheric pressure. It was invented by Galileo with his assistant Torricelli. Now the barometer is something like this. It has a long column in which mercury is filled. Any liquid can be used, but mercury is the liquid which has highest weight. So because of using of mercury, we can reduce the height of this column. So it has this column of mercury, and here there is vacuum, and this column is inverted into a container having mercury. So this all is mercury, and this region is kept open to the air. So if the atmospheric pressure increases in this region, then it will cause the mercury to rise in this column, and we can see the reading over here. And when the atmospheric pressure decreases, we will see that the mercury in this column will also decrease. So this indicates there is decrease in the pressure of that region. The normal reading is this one. So this is the normal atmospheric pressure. It is 760 mm mercury bar column height. So it is a long glass tube sealed at the upper and open at the lower end. So it is sealed at the upper end and open at the lower end. Lower end is inverted in the ball of mercury. So this is all mercury. Mercury surface is exposed to the air. Here we can see that the surface is exposed to the air. Variations in the atmospheric pressure on the mercury surface are balanced by the column of mercury in the glass tube. So any variation in the atmospheric pressure will cause a pressure over here. If the pressure increases, it will rise up, the column will rise up, and we can see over here, if the pressure reduces, then the column will go down. So this is how the balancing mechanism acts, which let us know what is the atmospheric pressure of that region. Now any liquid can be used, but mercury is the heaviest liquid, and therefore a shorter column is needed. If we were to use some other liquid which was of lighter in weight, then we will require a higher column of that liquid. Moreover, the thermal expansion of mercury is lesser compared to other liquids when the temperature increases. That is also an advantage of mercury. If air pressure increases, mercury rises in the column, and if air pressure decreases, mercury falls in the column. So this is how the measurement is done. This is one of the practical implementations of the barometer. Now there were some issues with the mercury barometer we saw in the last slide. The first one was that the mercury height, it varies with temperature. We know that almost all the liquids, it expand when heated and it contract when cooled down. So this mercury barometer, in that the mercury height will vary with temperature, and that is why it will give inaccurate reading. Moreover, it depended on gravitation, but we know that the gravity, it is not constant across the Earth's surface. It varies from one place to another. So this will also give an inaccurate reading. And it was also inconvenient for outdoor measurements because of the structure, the open mercury cylinder or ball which was there. It was not possible to carry it from one place to another. It was only for lab setup. That is why Aneroid barometer came up. And here is the structure of Aneroid barometer. It had a diaphragm which has a vacuum chamber. Now when the pressure increases, this diaphragm will contract. And when this diaphragm contracts, this rod, it will be lowered. And the amount of height that this bar is lowered, it will be measured by this spindle. It will indicate an increase in the pressure. And similarly, when the air pressure decreases, this will expand. And its expansion will be noted down by the spindle. So we will know that the atmosphere pressure has reduced. It is a metal container with vacuum created inside. This is the metal container. Increases in pressure cause lead to move inside. So because of increase in pressure, this lead will move, registering pressure on the revolving dial. So that will be indicated by this dial. Aeroplane used a modified type of Aneroid barometer to measure altitude as pressure decreases with height. So because pressure decreases with height, the Aneroid barometer can be slightly modified to measure the altitude, and that is why it was used for aeroplanes earlier. Now there is another type of pressure meter which is called barogram, and it is used for continuous measurement of pressure. So you can see that here there is a paper roll, and here is a device which expands or which contracts based on the atmospheric pressure, and the reading can be noted down by this head, which will make a mark on this paper roll. Millibar is the unit of measuring pressure. So remember, millibar is used for measuring pressure. Normal atmospheric pressure is 1013 millibars, and isobars is the line joining places of same pressure. Now temperature is again an important characteristic for measuring the atmospheric conditions. Thermometer is used to measure the temperature, and it works on linear expansion of mercury. So this thermometer, it has a mercury column, and this column will expand when the temperature increases, and it will contract when the temperature is lower. Now this expansion and contraction is linear, and therefore it helps us register the amount of temperature. There are two main units, Fahrenheit and Celsius. In Fahrenheit, the freezing point of water is 32 degree Fahrenheit and the boiling point of water is 212 degree Fahrenheit, while in Celsius the freezing point is 0 degree Celsius and boiling point is 100 degree Celsius. This is the method of converting Fahrenheit to centigrade and centigrade to Fahrenheit, and you do not need to remember this, you can just refer it. Now temperature can be measured in several ways. The first is temperature is measured directly in the sun. Here the effect of solar radiation is noted down by the thermometer. So this is called temperature in sun, because we are measuring the temperature in the solar radiation, in the presence of solar radiation. So the effect of solar radiation is also taken in account in this measurement. Second is shade measurement. So here we can see that this is the second measurement, second for the same place at the same time, and we can see the difference in the measurement. So this is called shade temperature, and temperature taken in shade. It is effect of solar radiation is removed. So the effect of solar radiation which would heat the thermometer, it is removed over here, and now the air temperature is recorded, and it is called shade temperature. Now for agriculture purpose, earth or soil temperature is also important. So there are instruments for measuring the soil temperature, and this is taken at different depths, and it is used for agriculture purpose. So it helps us understand whether the soil is ready for agriculture or not. These type of instruments could be used where there is rod which could be inserted in the soil to record the measurement. Now if you do not want that there should be some abrupt variation in the temperature, then the thermometer bulb is placed in a paraffin wax, so it avoids any sudden temperature change to be noted down. Now there is an instrument which helps us measure the maximum temperature and minimum temperature of a day, and it is U-shaped like this. Here is the column which is called for maximum temperature reading, and here is the column which is used for minimum temperature reading, and you can note the scales here. It has lower readings over here, and the readings increase towards the bottom, and here the lower readings are at the bottom and temperature readings increase with height. Now on the maximum side you will see there is vacuum in the bulb. However, on the minimum side there is no vacuum. Here there is alcohol, then there is this mercury, and then again we have this alcohol. Here we have a metal spindle or metal indices which is helpful in taking the reading. Similar metal indices can be seen on this side. Now the characteristics of these metal indices or metal indicator is that they float over the mercury column. So when the temperature increases, the alcohol column will expand, the mercury column will expand. So this will expand, and it will force this metal indicator to rise up. So the maximum temperature or the maximum extent to which the mercury expands, this will be locked to that place. When the mercury comes back down, it will remain at its position. The position is locked, so the maximum temperature reading is locked. Now similarly, when we come over here, during the night, when the temperature falls, the alcohol will contract, the mercury will contract. So both of these will contract, and the mercury will reach in the in this region, somewhere 0 degree or -5 degree, whatever is the temperature. So this metal indicator will float over the mercury and reach that place. Now when the temperature increases, the mercury column will again fall in this column, but the metal indicator will be locked at the minimum position. So this is how minimum and maximum position are measured using the minimum and maximum thermometer. Magnets, or generally a very wide shake, is used to reset this device, because once the metal indicator is locked, it will not come down on its own. So you have to give it use a magnet to bring it down, or you will have to just shake it wildly. So let's just read it. Maximum temperature, mercury expansion rate to push the indicator. This is the indicator. When temperature reduces, mercury comes down, so mercury will come down, but the indicator will remain at its position. If you want to make it come down, you will have to use the magnet. Similarly, for the minimum time, the tube is filled with alcohol. So here we have alcohol and here we have mercury. Temperature falls, alcohol contracts, drags the indicator up due to surface tension. When temperature rises, alcohol flows past the indicator. So when temperature falls, this will contract, the mercury will rise up, the indicator will rise up in this column, and it will reach the minimum temperature position. So it will indicate the minimum temperature. Now let's see what is diurnal range of temperature. So basically the maximum and minimum temperature difference of a day is called diurnal range of temperature. You will see these terms used when we are studying the different climatic conditions, because different climatic conditions will have different diurnal range. Now here you can see that this is the path of the sun, and this is indicating the amount of solar radiation or heat from the solar radiation that we are getting. This line, this blue line, it indicates the outgoing radiation. You can see that for this part, the incoming solar radiation is higher than the outgoing solar radiation. That is why we are retaining or we are gaining heat in this region. Therefore, the maximum day temperature is reached around 3 o'clock, because till here the amount of incoming solar radiation is higher than the amount of outgoing solar radiation. Remember, the sun reaches its peak at 12 o'clock, but because till here the net radiation which is received is higher, so the temperature keeps on increasing. Now after this point, where the outgoing radiation increases compared to the incoming radiation, we will see the temperature drop. So maximum temperature is noted at this point. Similarly, minimum temperature will be noted at this point, where there is again intersection between the outgoing radiation and incoming radiation. So these 2 points, they indicate the diurnal range of a given region. What is annual range of temperature? So difference between the hottest month, that is July in the northern hemisphere, and the coldest month, that is January in the northern hemisphere. The annual temperature range is also a good indicator of the type of climate. Here in this image we can see that this is the minimum average month temperature in a given year, and this is the maximum temperature of a month for a given year. So the difference between these two will give the annual range of temperature for a given region. Now let's see humidity, which is also an important characteristics for measuring the atmospheric conditions or the weather or climate of a region. Humidity is basically the amount of water vapor present in the air. It is also called dampness of atmosphere. Now there are several ways of measuring the moisture or humidity in the air. The first is absolute humidity, the second is specific humidity, and third is relative humidity. Now absolute humidity is based on the amount of water vapor in a given volume of air. So if I take a sample of air and if I extract the amount of moisture in that volume and I take the ratio of the amount or the mass of the moisture to the volume of the air, that is called absolute humidity. Here water vapor is present in atmosphere in grams per cubic meter, where cubic meter indicates the volume. The amount of moisture in unit volume is absolute humidity. Specific humidity takes into account the weight. If I take a sample unit air, I remove the moisture. Now I take the weight of the moisture and weight of the dry air. Then it is specific humidity. It is grams of water vapor per kilogram of dry air. It is ratio of weight of moisture to weight of dry air. But both of these are generally not used. The reason is that the amount of humidity that the air can carry, it depends on the temperature of the air. Temperature is very important, but both of these do not take into account temperature of the air, and that is why you will always hear about relative humidity, because it takes into account the temperature of the air. Now, relative humidity is the ratio of the actual amount of water vapor in the air to the actual amount of water vapor, or the maximum amount of water vapor that can be carried by the air at that given temperature. So here we can see this is the graph. Here we have mixing ratios, that is amount of moisture in the air. Here is the temperature, and here is the saturation line. So we can see this is the saturation line. This is the maximum amount of moisture air can carry at a given temperature. So if you try to understand the relative humidity, we can take this example. Now here there are two examples. First is with red and second is with blue color. So for red color, we have this point where the amount of water vapor in the air is 10 gram per kg. We can see it is on this line which indicates 10 gram per kg. So at this temperature, that is 30 degrees Celsius, the maximum amount of moisture the air can carry is here. So what is the maximum amount of moisture the air can carry? If you go over here, it is around 26 gram per kg. So if we take the ratio 10 gram which it is carrying and 26 gram which it can carry, if you take the ratio, it will come something like this. If we indicate in percentage, then it will be 38.46%. Now if we take this line, you can clearly see this is just below this 40% line. So this is our relative humidity. Similarly, we can take this example. Here also we are on the same mixing ratio, 10 gram per kg. Now here temperature is 20 degrees Celsius. The maximum amount of moisture the air can carry at this temperature is 14.5 gram per kg. We can extrapolate this and we can see it is slightly less than 50. If we take the ratio 10 versus 14.5, then we can see the ratio comes out like this. The percentage terms 68.96. So here you can see it is slightly below this 70% line. So this is how relative humidity is calculated. So we have seen that warm air can hold more water vapor than cold air. So here you can clearly see that when the temperature of the air rises, it can hold this much amount of water vapor. But when it is cooler, when the temperature is around 10 or 0 degrees Celsius, the amount of water vapor carried in the air, it decreases. So warm air can carry large amount of moisture, cold air can carry less amount of moisture. And when relative humidity is 100%, that is, it is on this blue line, air is completely saturated with moisture. Air temperature is called dew point. And here the moisture will condense to give clouds or precipitate in different forms. Now humidity is measured by hygrometer. It is an instrument for measuring relative humidity. It comprises of two thermometers, dry bulb and wet bulb. The difference is the bulb of this thermometer is kept open. But here there is a cloth, a muslin cloth which is dipped in water container. It constantly supplies water to the bulb of this thermometer. Now this thermometer will give you the actual reading of the room or the atmosphere. But this thermometer reading will be lower because its bulb is covered with this muslin cloth and water will evaporate from this cloth. So it will reduce the temperature and therefore slightly lesser reading will be seen in the wet bulb. Now this evaporation from this cloth will depend on the amount of humidity. So if the humidity is higher, that is almost 100%, then there will be no evaporation from this cloth. So the reading of both these thermometers will be equal. But if the moisture is very less, if it is dry, then the evaporation will be very high. Thus the reading will be lower and the difference will be very high. So this is how we measure the moisture in the atmosphere using this wet and dry bulb hygrometer. Another important characteristics of atmosphere is wind. It is air in motion and it has both direction as well as velocity or speed. Wind vane is an instrument which is used to measure the wind. Here is an example of this. Top part is an arrow which moves with wind. So this is the top part and it will indicate the direction of the wind. As the wind blows, it will be aligned with the direction of the wind, and lower parts, they are fixed and they indicate the direction of the wind. And remember one thing, winds are always named from the direction they are blowing. So the wind that is blowing in this will be an easterly or a wind coming from the eastern direction. Anemometer is used to measure speed of wind. It is something like this. They are these semi-sphere like things which are attached to the rod, and as the air will come, this will rotate and their speed will be transferred to a meter. So this is how they are measured. It has three or four semicircular cups attached to ends of the spokes. Rotated by wind, the rotation speed is then measured. So this is a very simple instrument to measure the speed of the wind. Now sunshine, that is the duration of sunshine for a given region, is also an important characteristic for determining weather or climate of that region. The amount of sunshine a place receives, it depends on the season. So if it is a summer season, the amount of sun received will be higher. If it is winter, the amount of sun received will be lower. Latitude, we know that on the equator we get maximum sunshine. It is both intense as well as longer. On the polar regions, the amount of sunshine is lower in intensity as well as the duration also varies. If it is summer, the duration will be slightly higher. If it is winter, then the duration will be lower. Position of the earth in its revolution around the sun. So here you can see that earth's position in the revolution around the sun, and there are regions like this North Pole. So when winter, there is continuous 6 months no sunlight, and in the summer on the North Pole you will have 6 months of continuous sunlight. So the position of earth in its path also determines the amount of sunlight received by a given place. Sundial is used to record the sunshine time. So this is a special instrument which has some lens over it, and here there is a paper which is inserted in this instrument. This lens will focus the light through this slit and it will cause a mark on that paper. So the length of the mark will indicate the duration of the sunshine. The dial is used to focus sunlight on a sensitized card graduated in hours. The line is made on the card when heated but not when sunlight is faint. Isohells are lines joining places with equal sunshine duration. Now another important characteristics of any weather or climate is the clouds. It is formed by rising air. When the rising air cools down due to decrease in pressure and expansion of the air, the temperature will decrease and condensation of water vapor occurs in the atmosphere. So clouds are basically tiny droplets of water vapor. They are tiny suspended water droplets which are too small to fall. So they are suspended in the air. The clouds' shape, height and movements tell a great deal about the atmospheric conditions. So their height at which they are formed, their size, they all indicate the amount of evaporation, the type of wind that is blowing, whether there is a convection current in that region or not. So all this can be judged from the shape and type of clouds which are seen. Now the cloud cover is measured in something called octaves or eighths. It is used to indicate amount of cloud cover in the sky. So 2 by 8 is quarter sky with cloud, and 4 by 8 is half, 8 by 8 is full. So here is the example. This is 0 octave, which means there is no cloud in the sky. 1 octave is indicated like this, 2 octave, 3 octave. So this is how it is indicated that how much cloud cover is there. And here you can see the example. Clear sky, 0% cloud coverage. Here 1 to 25% coverage, which is something like this. Scattered 26 to 50% coverage. And here is then 51 to 99, and this is 100% coverage. So this is how it is indicated in the charts. Isonapse is the line joining places with equal cloudiness. If you have liked the video, then do subscribe to the channel and share it with your friends. And if you like what we are doing, then you can support us using the Paytm ID. Thanks for watching the video.